Welcome back, everyone. Today we're doing something a little bit different with our explainer. It's a highly focused two-for-one educational session. We're going to tackle a unique challenge. We are going to walk step by step through solving a structural engineering problem while simultaneously mastering the essential technical English vocabulary that you're going to hear in real professional engineering spaces. So we're basically leveling up both your technical skills and your professional discourse at the exact same time. Here's our game plan for today. We'll start by approaching the engineering problem, then we'll dive into units, scales, and nuances. After that, we'll hit calculations and successive approximations, finalize our solution, and then wrap the whole thing up with a complete vocabulary review. All right, let's jump right into section 1, approaching the engineering problem. Okay, so before we even lift a finger to do some math, we've got to make sure our communication is crystal clear. Let's make sure our audio isn't distorted or garbled. If the sound is messed up, you're going to miss out on some seriously critical engineering concepts. Now, what exactly does garbled mean? Basically, it just means something is difficult to understand because it's distorted or all mixed up. Think of a really bad phone connection. You might say, the audio was garbled, so I couldn't hear the instructor clearly. Whether you're presenting in a boardroom or just using an ambient mic on a virtual call, avoiding garbled communication is step number 1. So moving on to our actual problem-solving strategy, we're going to tackle this thing step by step without getting too far into the weeds of things. We're keeping our eyes on the big picture first, like finding the derivative of a function so we can grab the slope of a deflection curve. You probably hear that phrase a lot, right? To get into the weeds. It's a great idiom that means discussing really complicated, nitty-gritty details. In structural engineering, it is super easy to totally lose your audience if you get into the weeds with complex math before you've even explained the overall goal. So, for now, let's not get into the weeds yet. Now, think about what actually builds a solid engineering solution. You need correct assumptions, proper units, accurate math, logical reasoning. All of these things constitute good engineering practice. In other words, they form or make it up. So you could say these equations constitute the complete solution. Definitely tuck that word away. It instantly levels up your technical writing. And that brings us to section 2, units, scales, and nuances. Here's something you really need to watch out for. You might have two equations that look practically identical, but a single tiny sign change can completely wreck your final answer. We call that a nuance. It's a really subtle difference or detail. For instance, there's an important nuance between these two formulas. Honestly, catching those subtle nuances is exactly what separates the seasoned pros from the beginners. This perfectly highlights our next big challenge. A lot of students tend to lump all unit conversion problems into one big category. But you can't really do that. Converting force, stress, and density all need completely different approaches. So don't lump into one group things that actually demand separate treatment. Unit conversion is a massive hurdle for FE civil students. Today, for our example, we're going to live in the land of US units for a bit, meaning we'll just assume everything is in customary units right now. But don't worry, later on we'll jump that hurdle and convert everything back to SI units. Sometimes, though, the scales we work with shift dramatically. When dimensions get incredibly small, like all the way down to the atomic level, engineers and scientists use a unit called the angstrom. An angstrom is a unit of length equal to 10 to the power of -10 meters. So you'd say atomic distances are measured in angstroms. It's a super specific term, but absolutely crucial depending on your field. All right, moving right along to section 3, calculations and successive approximations. As we dig into this structural engineering problem, we follow a pretty strict 3-step process. Step 1, we perform our initial calculations. Step 2, we make successive approximations. And successive just means occurring one right after another, right? Each successive guess gets us a little bit closer to the truth. And finally, step 3, we wait for the solution to converge. Now, I will warn you, occasionally during this convergence step, your software might just completely freeze up trying to process all those heavy iterations. If that happens, hey, don't panic. You might actually hear an engineer say, "Man, my copy isn't kicking it today." That's just a really colloquial way of saying my version of the software isn't performing well or working properly. Like, my copy isn't kicking it after the latest update. It happens. That's exactly why you always want to be ready to verify your calculations manually. Okay, we are in the home stretch, section 4, finalizing the solution. Whoa, goodness gracious, we actually just found a massive calculation error in our work. Thankfully, we caught it before sending this design out the door. Now that we fixed it, you know what? I don't want to steal your thunder, so I'll let you solve the final step yourself before I walk through the complete solution. Go ahead and get hands-on with the math for a second. And just a quick aside on that phrase, to steal someone's thunder means taking the attention or the credit away from them. By having you solve this final piece, you get all the credit for the correct answer. It's a fantastic little phrase to keep in your back pocket, especially when you're working on collaborative design teams and you want to make sure you're not overstepping. Once you have that final answer, we need to incorporate or integrate everything we've learned today into one final equation. If you pull up your notes right now, meaning just open them up and display them, you'll see the whole process mapped out. And trust me, doing this kind of methodical work right now is absolutely going to pay dividends for you later. That just means it's going to produce highly valuable results down the line. Daily vocabulary practice will pay dividends, especially when you're sitting in that exam room taking the FE civil test, and literally every second counts. And that takes us to our final stop, Section 5, Complete Vocabulary Review. Let's do a rapid-fire recap of our first set of terms. First, garbled. That's the distorted, messy audio you definitely want to avoid. If an engineering design is just fundamentally bad, you scrap it or abandon it entirely. On forums, you might give a really helpful post an upvote. Mathematically speaking, the derivative is simply our slope. Remember, try not to get into the weeds with complicated details too early on in a presentation. Valid, sound assumptions constitute or make up a good solution. And always, always be mindful of the background noise on your ambient mic. Moving on to batch number 2. A nuance is that really subtle but super vital difference between two things. Be careful not to lump completely different concepts into the same category. A hurdle is an obstacle you've got to clear. The angstrom is used to measure incredibly tiny distances, all the way down to 10 in the negative 10 meters. Successive steps are things that happen one right after another. And hey, if your modeling software starts freezing up on you, it's safe to say your copy isn't kicking it. Rounding out our list for today, goodness gracious is a great polite exclamation of surprise. Don't steal someone's thunder by grabbing credit that you didn't earn. Make sure to incorporate or integrate your findings into your work. Always pull up your notes so you can review them, because putting in this effort now will pay dividends and produce massive results for you later. And finally, living in the land of US units just means you're temporarily doing all your math in customary units. But before we totally wrap up this explainer, I have to share one last absolutely critical tip with you. Always check for a typo. A typo is literally just a typing mistake. Your underlying equation could be absolutely flawless, a thing of beauty. But if there is a typo in the units, or even just a single misplaced decimal point, it can completely ruin a structural calculation. So always, always double check your work. I'll leave you with this final thought for today. Mastering technical English, it's a process. It doesn't happen overnight. But little by little, you'll get into the groove of things. Meaning you'll get comfortable and find your rhythm. And suddenly, reading those dense engineering textbooks is going to feel so much more natural. Every single example you solve is a step forward in your professional growth. So I have a question for you. What nuanced engineering term are you going to incorporate into your own vocabulary today? Keep learning, keep practicing, and I'll catch you in the next explainer.